Hey everyone! Today we're going to dive into a story that starts with, believe it or not, a piece of fruit, and it ends with the rules that run the entire universe. It's the story of gravity and how one incredible idea connected our world to the stars.
So it all really starts with this one simple question. What does a falling apple have to do with the moon orbiting the Earth? On the surface, they seem like they have nothing in common, right? One is this tiny thing falling a few feet, and the other is a gigantic rock that seems to just float in the sky. But, as we're about to see, they are two sides of the very same coin.
All right, so the key to cracking this whole puzzle came from one of the greatest minds in history, a guy named Isaac Newton. And the legend of how he figured it out begins, like a lot of great stories, in a moment of just quiet thinking.
Now, you've probably heard this story. And look, whether the apple actually bonked him on the head, we're not totally sure. But the important part is true. Seeing an apple fall wasn't anything new. But what Newton did next, that was different. He didn't just see it fall, he asked why. Why did it fall straight down? Why not sideways or even up? What was this invisible thing pulling on it?
And this right here, this is the brilliant leap. This is the moment of genius. Newton wondered, hey, if this force can pull an apple to the ground, maybe it reaches out way, way further. Maybe, he thought, that's the exact same force that's holding the moon in its path around the Earth. That idea was an absolute game changer.
So what is this force that Newton was thinking about? Well, it's something that you and I experience every single second of our lives, usually without even giving it a second thought.
So here's the basic definition. Gravitational force is the pull that the Earth has on everything, from you and me to the tiniest speck of dust. And here's the super important part. It's always a force of attraction. Gravity only ever pulls things together. It never, ever pushes them apart.
And what's really cool is that gravity isn't just some abstract space concept. It's the reason we're alive, really. It holds the very air we breathe close to the Earth. It's why rain falls down to water the plants. And of course, it's what keeps us from just floating off into space. It's about as practical as it gets.
Okay, so we've got a handle on what gravity does for us here on Earth. Now, let's zoom out and see how that very same rule explains the cosmos. This is where Newton's idea about the moon really comes into focus. This is a concept that can kind of bend your brain a little bit. The moon isn't just floating up there. It's actually in a constant state of falling. See, it has a ton of sideways speed, enough to keep missing the Earth as it falls. So gravity is always pulling it in, bending its straight path into a circle or an orbit. It's kind of like throwing a baseball so incredibly fast that it falls all the way around the world.
And this slide just lays it out perfectly. On the left, that's our reality. Gravity acts like an invisible string, a centripetal force that keeps the moon swinging around us in that orbital dance. On the right, well, that's what would happen without gravity. The moon would just shoot off in a perfectly straight line and we'd never see it again.
So, the big takeaway here is that the rule for the Earth and moon is the same rule for the sun and all of the planets. The sun's incredible gravity is the anchor for our whole solar system, holding Earth, Mars, Jupiter, all of them, in their orbits. The same law applies everywhere.
Okay, but this brings up a pretty logical question. If everything with mass has gravity, why isn't your coffee cup pulling your keyboard towards it? Why don't we feel the pull from, big buildings next door? Let's break that down.
And this is the perfect way to think about it. Newton's laws tell us that forces are a two-way street, so if the Earth pulls on the apple must be pulling on the Earth with the exact same amount of force. So what gives? Why does it look like only the apple is doing the moving?
The answer, in a single word, is mass. The force might be the same, but the things that force is acting on are just wildly different. An apple's mass is basically nothing, while the Earth's mass is almost too big to even imagine.
And here's the physics principle that makes it all make sense. It comes from Newton's second law of motion. Basically, if you apply the same push to two different things, the lighter one will speed up a lot, and the really heavy one will barely even budge.
And there it is. That's our answer. The Earth does actually move toward the falling apple. But because our planet is so ridiculously massive, its acceleration is so tiny, so infinitesimally small, that it's completely impossible for us to ever notice it. The effect is there, it's just too small to see.
So, let's bring this all home. This whole journey, which started with a guy just watching an apple fall, led to one of the most powerful and profound ideas in all of science, universal gravitation. It's not just that the Earth attracts things, it's that every object with mass in the entire universe is pulling on every other object.
And that leaves us with a pretty cool final thought to chew on. Right now, wherever you are, you're being pulled on by the Earth, sure, but also by the Sun, the Moon, Jupiter, and even the most distant stars. You're part of this invisible web of forces that connects you to everything else in existence. And to think, that incredible idea all started with a simple falling apple.